Okay, we're going to look at a few examples here of finding slopes of tangent lines and doing a couple of other things with tangent lines to curves. Okay, so this problem says find the slope of the tangent line to f of x equals x squared at x equals 1. Okay, so depending on how much calculus you've had before, you may know a couple of ways to do this problem. So for my class, at this point, we have covered how to do this using the definition of the slope of the tangent line. And on the first exam and on any assignments that specify using the definition, you have to do it that way in order to get credit. So I'm going to do these problems using the definition of the tangent line. There are other ways to do this problem that we will learn later, and you may already know if you've had a little calculus before, but for these, we're going to do this using the definition. So the first thing you have to do is remember the definition. That's one of those things I said you need to memorize. So you need to memorize that. I'm going to put it right here, but you might pause the video, practice writing it down, and then check to see if what you did is right. Okay, so here's that definition you're supposed to have memorized, so hopefully you know that. Okay, so we're going to do this problem using that definition. That's what you're going to be expected to do on the first exam. Okay, so we're going to basically start by just writing down that definition. So limit as h approaches 0, don't forget that part. I a lot of times like to just start by writing down that definition, maybe with the value of c plugged in. So we're doing this at x equals 1, so that's our c. So I'm writing down just that definition with 1 in place of c. Okay, and then I'm going to use this definition on the function that we have. So I'm going to write LIM, h approaches 0 out front in every single step until I evaluate the limit. Alright, so when it says f of 1 plus h, I'm going to take that 1 plus h and put it into the function in place of x. So I will have 1 plus h, the quantity squared, minus, and then when I have f of 1, I'm going to put 1 into the function in place of x. So I'll have f of 1 is 1 squared, and then I have the whole thing over h. Alright, so basically all I did right there was use that definition that we had up here, and I did it with the particular function we're working on, f of x equals x squared, at the specific value of c equals 1. Okay, so that's the first step, is being able to write that down correctly. Then the next few steps involve some algebra. Sometimes the algebra can be tricky and sometimes it's not too bad. And then at the end, you're going to evaluate a limit. So you need to make sure you write the LIM in front of every single step until you're done doing that and ready to evaluate the limit. Okay, so I'm going to expand out 1 plus h, the quantity squared. And so that's really 1 plus h times 1 plus h, and I have to FOIL that out. And then I'm going to go ahead and simplify. The 1 squared is just 1 all over h. Alright, I might try to evaluate this limit. I cannot use a substitution shortcut because of the denominator. That would be 0. So I'm going to keep working on the numerator here. I have a couple of like terms that cancel, my 1 and minus 1. So I get limit as h approaches 0 of 2h plus h squared all over h. I might notice that I have a common factor of h in the numerator. So I'm going to factor that out. H times 2 plus h all over h. And then I get those h's to cancel. And then I am left with a new function. So this is a function that agrees with the previous function at all but one point. So the previous function, I was not allowed to use h equals 0. This function, though, that I have now does include h equals 0 in its domain. And it's a polynomial, so I can just use a substitution shortcut to go ahead and evaluate that limit. And so I get 2. Alright, all that work to get 2. A couple of important things. Notice that I wrote LIM, h approaches 0 in front of every step until I actually evaluated the limit using that substitution shortcut theorem. So I wrote that LIM in front of every step until then. That's important to make sure you look back and make sure you do that. The other important thing would be to make sure you think about what what this number that I got here at the end actually means. So it means that if I think about the function f of x equals x squared, and I think about at the point x equals 1, and I draw a tangent line to that curve at x equals 1, that the slope of that tangent line, m tan, would be 2. That's the slope of that tangent line at that point on that curve. Okay, so we're just going to look at some more examples. The algebra gets messier when the functions are messier, but other than that, it's pretty much the same idea. Okay, so again, we're going to do this using the definition. So you're going to make sure you write down that definition, and we're going to apply it to this function at x equals 3. So m tan equals limit as h approaches 0. All right, I'm going to just write down the definition with my 3 in place of the x value that we're using here. All right, so that's just straight from the definition. And then the next step I'm going to do, I'm just going to apply that definition to the particular function that we're working on. So limit as h approaches 0 of 1 over 3 plus h minus 1/3 all over h. Okay, so we did a little simplifying there. The first video for this week was algebra review, and there was some review of some algebra like this. So if you're getting a little hung up on this algebra, you might go back and watch that video again. It's the algebra review video for the beginning of this week. But what I have here is a complex fraction, a fraction within a fraction. We don't want to leave it like that. So there are several ways to simplify it, but I would probably do this. I would probably write the numerator 1 over 3 plus h minus 1 over 3, and then instead of having that whole numerator divided by h, I would have that whole numerator times 1 over 8. So multiplying by the reciprocal is the same thing as division. Okay, so then the next thing I'm going to do here is simplify what I have in the brackets. I'm writing the LIM in front of every step. I'm going to go ahead and get a common denominator for these two fractions that I have in the parentheses. So I'm going to multiply the first fraction by 3 on numerator and denominator, and then on the second fraction I'm going to multiply that by 3 plus h on the numerator and denominator. So both those fractions have a denominator of 3 times the quantity 3 plus h. Alright, so when I do that, then I can go ahead and combine this into a single fraction. So the 3 times 1 is 3 minus the 1, I'm going to go ahead and write a 1 there, times the quantity 3 plus h all over 3 times 3 plus h. And I can simplify what I have on the numerator a little bit more. If I distribute through that minus sign, make that plus a negative and distribute that through, I will have 3 minus h over 3 times 3 plus h. Okay, be careful with what you can and cannot cancel. I have a couple of like terms on the numerator that add up to 0, so I can go ahead and add those up. Then what I have left in this second fraction is negative h over 3 times the quantity 3 plus h. So here I have a couple of fractions, and I have a common factor of h on the numerator of one and the denominator of the other, so I can cross cancel. Again, if you need that algebra review, go watch that video from the beginning of this week. So limit as h approaches 0 of, multiplying straight across, I get negative 1 over 3 times 3 plus h. Okay, and up until that point, although what I'm really after is a limit here, I really couldn't do much to evaluate that limit. I could have used tables of values or things to maybe help me think about that limit, but I sure couldn't plug in, use a substitution shortcut and plug in h equals 0. So I'm still writing LIM in front of every step. But now when I get here to the end, after I did that last step of canceling those h's, this function that I ended up with here, I actually can use a substitution shortcut, and I can just plug in h equals 0. Remember, the limit is not really about what happens at h equals 0, but sometimes you can get away with that simplification. Alright, so on the denominator here I have 3 times 3, which is 9, so negative 1/9. So that's the slope of my tangent line on the graph of that function at x equals 3. And if you just imagine a little bit what the graph of that function looks like, that might be when you know what the graph looks like at least well enough to get a rough sketch. And over here at x equals 3, you're going to have a tangent line with a negative slope and pretty shallow tangent line, so you'd expect a negative slope fairly close to 0. Okay, let's do one more in this video. Okay, so this problem asks about a tangent line, but one important thing to notice here is that this one does not ask us for the slope of a tangent line. It asks us for the equation of a tangent line. So one thing that we might review is thinking a little bit about how to write the equation of a line. So there's a couple of forms you probably know for writing the equation of a line. Y equals mx plus b works great if you know slope and a y-intercept, or there's also a point slope form. Y minus y1 equals m times the quantity x minus x1 if you know a point and a slope. But for either of those, you need to know a slope. So the first thing that we want to do is find the slope of the tangent line. We're going to do this one again using the definition. So limit as h approaches 0, f of, here we're at 9, so 9 plus h minus f of 9 all over h. So this is just going to give us the slope, and then I'll need to go back and finish and write the equation of the line. Okay, so let's apply this definition that I wrote down here to the function we're working with. So I'm going to put 9 plus h into the function in place of x, and then 9 into the function in place of x. And then I want to simplify. So the square root of 9 at the end here, I can just make that 3, but that is about all the simplifying I can actually do on this one. So we might look at this and try to think about if I can do substitution shortcut, but I can't. So we might think a little bit, and then hopefully it occurs to you that you did problems like this when we did limits, and there was a special trick that made some simplification happen that's not exactly obvious that it's going to happen, and that was to multiply by the other factor from a difference of squares. So we were rationalizing the numerator. So we did that when we did some limits earlier this semester. Alright, so that is a trick that is maybe not immediately obvious that you would do that, but that helps get some simplification going here, and then we should be able to finish this limit that we need to do. Okay, so when I FOIL this out, I've got square root of 9 plus h times square root of 9 plus h, which will be square root of 9 plus h squared, or just 9 plus h. And then part of why this works is that when you do the FOIL, the outer, so that would be 3 times the square root of 9 plus h, in the inner, so minus 3 times the square root of 9 plus h, those two terms cancel. So 3 times square root of 9 plus h minus 3 times the square root of 9 plus h. So I'm going to go ahead and write those out. I don't always write those terms out, but just so you can see them in action here. Okay, and then I got the last part of FOIL, so minus 3 times 3 will give me a minus 9 here at the end. All right, so the canceling those two, or what I was talking about, canceling. All right, and then on the denominator, I'm going to just leave that factored. So h times the quantity 9 plus h, square root of the quantity 9 plus h, and then plus 3. Okay, so I had these like terms on the numerator, 3 times the square root of 9 plus h and minus 3 times the square root of 9 plus h that added up to 0. But I also have some other like terms that'll add up to 0, so the 9 minus 9. All right, so I'm going to go ahead and write this out. My limit is messy there. Looks like just an h left on the numerator, and ooh, that is pretty convenient because that allows us to cancel with the h that's on the denominator. Yahoo! Okay, so the canceling's the fun part. Alright, so here looks like we're left with 1 over square root 9 plus h, and then a plus 3 on the denominator. So then I can go ahead and use a substitution shortcut theorem and finish this off. So I'm not writing LIM anymore because I'm actually evaluating the limit. Alright, so on the denominator it looks like I have a square root of 9, which is 3, and then plus another 3, so I get 1/6. All right, so unfortunately we're not all the way done with that. That's our slope. And then I need to write the equation of a line. So I could put that in for slope in either of those two formulas, but then I either need to know the y-intercept or I need to know another point on the line. And I don't really know the y-intercept. I have an x-coordinate, so I could use that to either find the y-intercept, or maybe easier is just to find the y-coordinate at that x value. So at x equals 9, if I want to just find the y-coordinate, I'm just going to plug that 9 into the original function. That's what the original function gives you, is input, output, x, y coordinates. So the point that I'm writing the equation of this tangent line at is 9, 3. All right, so I have a point and a slope, which means I'm going to use point-slope form. You can use slope-intercept form, but there's a lot more steps involved if you're going to do it that way. Okay, so I think I'm ready to write my answer. So the equation of the line that I want here, I'm going to have y minus, my y1 is 3, equals m, my m is 1/6, and then times the quantity x minus x1. My x-coordinate is 9. Okay, there's the equation of a line. It's not in a very simple form, but that's the equation of a line. Technically, from the way the question's worded, you could stop there if you want. If you want to do some housekeeping and maybe solve for y or something like that, or write it in standard form, you can do that as well. But that's not really necessary unless you specifically want your answer in a special form. Sometimes online homework will ask you for it in a special form, so I'll go ahead and simplify this. Let's see, if I distribute through the 1/6, I'll get 1/6 x minus 9/6, which reduces to 3/2. And then maybe I want to write this in y equals mx plus b form. So from there, I would just add 3 to both sides of the equation. And so I'd get y equals 1/6 x plus, and then negative 3/2 plus 3 is plus 3/2. All right, so there's another form of the answer. But I just want to say that unless it specifies a specific form, then you could leave it like this. This is an okay answer for the way the question is worded. This is if you want your answer in slope-intercept form. Okay, we'll do a couple more examples in the next video.